Okay, welcome Caledon. This is, so far it's just you, but hopefully others will show up. So let me tell you the plan today. This is the week 10 webinar. We're almost done with the course. So this is the penultimate webinar. So next week will be our last webinar of the quarter. And this week is the last regular one where, it's all about new material and not review or anything like that. So the plan today, it's actually a really important day in terms of how practical it is. And that is, we're going to be looking at a regression analysis. So very easy to come up with examples that are real life or whatever that kind of show what's up. So, so again, we're going to do regression analysis, which is the chapter 12. So chapter 12, it's a long chapter. Just let you know that next week we do chapter 13, but that's a short one. That'll be really simple. So we're going to be doing chapter 12 today, which is regression analysis. And that's all about looking at comparing two different quantitative variables to see if, as one goes up, what happens with the other one. Does it tend to go up? Does it tend to go down? Or maybe nothing is predictable at all. And in particular, we're going to be doing linear regression. So is it a linear relationship or not? So I want to remind you, 2 weeks from Wednesday, what happens?
The final.
Yeah, so the final must be taken by 2 weeks from Wednesday. So 1 week from Wednesday, you are required to have your final exam information sent to me. And if it's the same as the last one, all you have to do is say the same and tell me what day you're taking it, and that's good enough. Very simple. Okay, most people just do the same information as last time, as the midterm, but that's up to you. The other thing is what's due this Sunday.
Project number 2.
Yeah, project 2, and that's a big piece. So I want to let you know, unfortunately, I have some busy times coming up. I am on an interview committee Thursday and Friday all day long, where we're interviewing for a position at our college, and I have to be one of the interviewers to do that, which means I'm not going to be available much Thursday and Friday. I'll check my email at like 6 in the morning, and then maybe at night, and in like 8 in the evening or something like that. But those 2 days, I'm kind of not available. And then so far scheduled is I have a conference on Saturday at which I'm giving a talk at. There's a chance that gets canceled. Any guess on why?
Shutting down the school.
Yeah, it's just left and right. I hear one school after another shutting down. And for what they're doing is they're turning into all online, so it won't affect you guys really at all if we shut down, other than proctoring issues. But the good news is that this is an online class, so it's not a big deal. The bad news is that, man, I'm on the state board for math, and I'm hearing college after college is shutting down. So hopefully ours doesn't. So I know that, for example, Sierra College is shutting down for anything that's not labs. Then there's Skyline College is shutting down, Berkeley and Stanford, USC. There's a lot of California colleges that are just shutting down. I think it is overreacting, because I've looked at the numbers, and the numbers are tiny in terms of the data. There's just not a lot of people affected, and especially healthy people like, college students. But we have to do what we have to do. So if there's any issues, I'll let you know. But again, it's an online class, so there probably won't be any issues. But I'm going to be busy Saturday also. So in terms of help with your project, today, tomorrow, and the next day are the 3 days where I can do a lot of help with your project. After that, I'm kind of packed, unfortunately, and I'll only be able to answer quick questions mostly. So that's just a note. And I wish I could help more, but life happens sometimes. But if everything shuts down, I'll have lots of time. I'll be sitting at home with nothing to do as long as I have internet. Okay, so just some plans. Wash your hands a lot is what they say. Otherwise, yeah, act as normal. Are there any questions at all about anything right now? The project, final, or anything else that's going on? Caledon or Pooja?
Nope, nope, not at the moment.
Okay, no questions?
No.
Okay, what I want to do, one of the things I like about this is it's really easy to grab like information I care about. And I'm trying to remember, are either of you from Tahoe?
No.
No?
Nope.
Oh, well, I'm from Tahoe, so I care about Tahoe. Sorry about that. But so I grab stuff about that's relevant to us. And I have a couple things to look at that are real life that just came to my attention. One came to my attention this week. I got an email from the Keep Tahoe Blue organization, and it's about climate change. So let me share my desktop. Let me find it. That one. Okay, so this is a newsletter that came into my mailbox, and I'm like, hey, this is what we're gonna be talking about. And it just came like pretty recently, not too many days ago. So here's what it says. Where did winter go? I don't know if you've thought about it. So even if you're not from Tahoe, you're from not too far from here, I think, right? You're both Californians, right?
Yeah.
Okay, so January and February have been disappointingly dry and warm in Tahoe. Okay, leaving our Sierra snowpack far under par. Okay, et cetera, and is this the effect of climate change? So if you want to study climate change, what you do is you look at the data. Okay, the first thing you do is you look at the chemistry, and they've already done that. And then what you do is you look at data and see if there's been any change. So what they were able to do is they came up with a just a chart, and we're looking at snow as a percentage of annual precipitation since 1910. And if you look at each individual stuff without looking at this dashed line, it's just all over the place, isn't it? But if you look at the long trend and you really look at the data, you'll notice that the percentage of snow has gone down as an average percent. Okay, and what they have done is they have drawn what's called the regression line for this data. So any questions about looking at this before we look at it a little bit further? Any questions? Okay, and by the way, again, even it's not about necessarily about being in Tahoe, but why do you care what the percent of snow versus rain is in Tahoe if you live in California? Any thoughts? Both of you should care because it affects you personally. No idea?
Because we've been in droughts.
Yeah, because I don't know if you realize, but your water comes from our snow. And if it rains all winter instead of snows, all that rain just goes into the ocean. On the other hand, if it snows, then that snow hangs out and then waits a while, takes it time to melt. And then when you need it, that's when it melts. Okay, and that's just how it is in California. And what we're looking at is if you look at over time, you'll see that there's been a tendency for a smaller percentage of snow versus rain over time. Can you see that from the picture, from this chart? Okay, this dashed line that we're looking at is called the regression line. What that does is it gives you the best linear approximation for the data. And there's, hopefully you remember a little bit of algebra at least. When you have a line, what are the two important numbers for a line? See if you can remember. What are the two important numbers that come up when you look at a line? Very basic math is a hint. Basic algebra.
The slope.
Yeah, slope is one of them. And what's the other?
I don't know.
Do you remember, Lucia?
No.
No, slope and y-intercept. Does that sound familiar?
Yeah.
Those are the two big numbers that, y equals mx plus b. Remember that? Okay. Turns out in statistics, we usually don't use mx plus b. Those letters, we use a plus bx. But same idea. So what I want to look at is, first let's look at the slope of this line. It's called the regression line. And one way of finding the slope is rise over run. Is that clear? So for this example, it's looking like in 1910, looks like it was around 52. So I'm going to write this down. So 1910, we had 52. And then in that, I believe that is 20, I don't know if it's 18, let's say 19. That looks like around maybe 39. I'm just eyeballing it. Okay, they don't actually tell you the exact numbers, but if I really wanted, I can find out probably. Any questions so far?
No.
Okay, so then if we are given 2 points, we can find the slope as the rise over the run. Do you remember that? So I think we'll look at it and we'll say the slope is the rise over the run, which is 39 minus 52. Okay, in other words, you subtract the y coordinates and then over subtracting the x coordinates, which is 2019 minus 1910. Any questions on that so far? Okay, and again, pop that in your calculator. 39 minus 52, and then divided by 2019 minus 1910. And you get about negative 0.12. Any questions on that? Okay, so how do we interpret that? So our slope is negative 0.12. So what that says is the slope is a rise over the run, okay? And if you want, you can write negative 0.12 as, say, negative 1.2 over 10, just as a fraction. Sometimes it helps to write it as a fraction so we can see that. So the way you can interpret this is you say, well, what is a rise? A rise is a change in the y coordinate. Is that clear? So in particular, the change in the y coordinate is negative 1.2. And that's a percent of rain to snow, basically. Okay. And the run is the year. So if I put over 10, that's 10 years. Is that clear? So what we can say now is that for every 10 years, on average, we have had a drop in snow percent, snow to rain, snow percent as opposed to rain by 1.2%. So what that's saying is that we're getting less snow, okay? And the drop is 1.2% per decade on average. Any questions, Cal?
Nope, not now.
Does that make total sense?
Yeah, I'm getting it.
Okay. So again, that's really important. What I didn't do is tell you how to get this line. They just show it to us, right? But we can take a look. Now, in terms of the y-intercept, why is the y-intercept irrelevant here? Any thoughts, Cal? Who just left us for a bit? It's just you.
Irrelevant for finding the slope.
Just irrelevant for this situation, for this particular example, where it's a year for the x-axis and the snow percent, the percent of precipitation that is snow for the y-axis. Why is it pretty irrelevant?
I don't know. It seems it seems pretty relevant to me.
Okay, what was happening in the year 0?
We do not know.
Not much, right? There haven't been people here for more than a couple hundred years, right?
Yeah.
In Tahoe. And you may not know our history, but Tahoe's you probably know Tahoe's a ski resort. You know that?
Yeah, I lived there last year.
Oh, okay, so you know Tahoe. Okay, so Tahoe's a ski resort. 100 years ago, even it was way too cold to live here full time.
Oh, okay.
Do you believe that?
Yeah.
Before technology, you just die in the wintertime.
Oh, yeah, that's true.
Yeah, and in fact, 150 years ago, I think it was, there was a Donner Party.
Yep, I heard that story.
Yeah, and they were eating what they needed to eat because that was all they had. So you can imagine what almost 2,000 years ago was, or actually over 2,000 years ago. Does it make sense?
Yeah, I see.
There have been people for most of that time. So it's so out of our ballpark that year, the year 0, that it's not relevant.
Okay.
And especially if we're looking at this due to global warming is a pretty new thing. It wasn't happening 500 years ago, right? So that was not any thought that temperature was rising 500 years ago. Do you see that?
I got it, yeah.
So in this case, the y-intercept is not relevant. So the y-intercept will not be relevant if 0 makes no sense. So if it's just out of our ballpark, or if the y-intercept number could make no sense also. So for example, if you ended up with a percent of -70, okay, or actually more likely 150, but you can't have 150%. Does that make sense?
Yeah.
So, and my guess is if I put it in the equation, I'd probably get some kind of number over 100. Does that make sense?
Yes.
Okay. So this case, the y-intercept doesn't make sense. Sometimes it does make sense. I just want to let you know that. Aha, now we got Pooja back, and Alexandra, thanks for coming. So we're just going over this example of why we care about regression analysis. So what we can do is we can find the y-intercept, and let's do that. So if you find the y-intercept, again, we've got the slope. We can say y minus 52 is equal to -1.2 over 10 times x minus 1910. Okay, find the y-intercept by setting x equal to 0. Okay, even though it's not relevant, it's still going to help with the equation. And if you do that, you get y equals 52. And then we have a plus 1.2 over 10 times 1910. And let me do that on Google, on my calculator, which is 52. And then plus 1.2 over 10 times 1910. Yeah, and I get 281.2. So what we can say is that the equation is y equals 0.12, negative 0.12, plus 281.2. And as I mentioned, you also can't have a y-intercept being 281 because this is a percent of snow. And you can't say, oh, well, 281% of precipitation is snow. That's just stupid. You can't have over 100%. Is that clear? Okay, so now what we can do is we can say, well, now we have this regression. We have this regression line, negative 1.2x plus 281.2. And we can make a prediction. We can say, well, what might it be like in, say, 2040. Does that make sense?
Yeah.
So what do you think the precipitation percent will be in 2040? Well, all we have to do is plug in 2040 for x. Is that clear?
Mm-hmm.
And you get negative 0.12 times 2040, and then plus 281.2. And what I get is about 36.4%, or 36.4. So what we're looking at is if climate change continues on, then our best prediction for the percent of snow versus percent of snow as participation will be 36.4%. Okay, and that's bad, by the way, right? Notice in 1910, we were over 50% snow. And that's a big drop. So what's happening is Tahoe is going to lose a lot of its snow. Any questions on that? Any questions? Does that make sense?
Yeah.
Okay, so that's an example of using the regression line. We've got data, and notice that it's quantitative data, and it's two variables, where in this case, X was year, Y was percent snow. And what we want to do is we want to say is if X increases, what happens to Y? In this case, we see that if X increases, Y tends to decrease. So I want to emphasize that word tends to. Okay, this is not causative. We cannot say that the year is causing it to happen. The other thing is, if you look at the data, in fact, you'll see there are years where pretty recently, like in maybe 2022, there was very little snow, a lot of rain. But then in 2023, there was a whole lot of snow. It spiked up. Do you see that? And it went up instead of down. So this does not tell you what's going to happen every year. What it does is it gives you a tendency over time. Any questions on that? So let me tell you some forbidden words in chapter 12. One forbidden is cause, because it doesn't, the year does not cause the increase. Other things cause it. Another is because that's the same thing. You can't use because when you're doing any kind of explanation. Another one is will. Okay, because will means you know for sure, and it just always happens, and that's not true. Is that clear?
Mm-hmm.
Okay, so that's an example of some of what's called regression analysis. So again, we've got a line has a slope and a y-intercept, and you go from there. Okay, let me give you another one. And this one is, I've actually set this one up, and it's got a story. There's some history involved. All right, so I cut this one off on purpose. So if we look at what this is, by the way, is Lake Tahoe clarity. So Cal, you said you lived up here, so you know what I'm talking about, right?
Yep.
Good. And Pooja, you don't live here, but maybe you can understand. What they do is they every year, they take some measurements and how far down you can see. They take what's called a sea key dish, which is just a plate, basically. They let it drop down with a string, and they keep going until they can't see anymore, and they see how long the string was. Okay, and that's how it's done. And they've been doing that for a lot of years. Okay, you can see since the late 60s. And this is a little tricky, so let me tell you about the trickiness. And it's because what UC Davis is the one that does this research, because the way they did it is that, notice the y-axis, anything weird about it?
It doesn't start at 0.
Doesn't start at 0, that's not too big a deal. Okay, there's a bigger deal. that could be tricky? So here's a hint. If you look at the data, as time goes, is the slope positive or negative?
Negative.
Yeah, the slope is negative, and that's tricky because it looks positive, doesn't it? But it's actually negative because the y-axis is upside down. Does that make sense? Okay, so let me tell you a little history, and this was, I actually got the information from a student of mine, I've been teaching a long time, and the President of the United States came to Tahoe, and that's pretty amazing, by the way. We're not that big a city or anything. And there was it was a global summit on environmental, or not a global summit, a national summit on environmental stuff. And the UC Davis came and showed this picture. And at the time, President Clinton was actually our president. And the cool thing is, one of my students was his waiter, or waitress, actually. She was in my statistics class. So she got to see this all happen. I didn't. I wasn't allowed in that restaurant because I'm not famous. Okay, and I don't work there either. So what happened is that they showed him this picture. Now, I don't know if you know much about Clinton. Do you think Clinton understood science? See if you know your history. Or at least understood it and respected science?
Yeah.
Yeah, it turned out he did, and he knew statistics. He was a very bright guy, by the way. And they showed this to him, and he understood the regression analysis. And we can see that as time is going down, what's happening to the lake as time increases?
We're losing visibility.
Yeah, we're losing visibility. So we can see in the 70s, we're looking at visibility, around maybe in 1968 or so, maybe 1970, we had a 30 visibility, right? Okay, maybe 30, so maybe 29. And then by 2000, we're looking at it tends to go around maybe 21. Okay, so in 30 years, we've lost 9 meters of visibility. 9 meters is a lot, by the way. Okay, so what we can say is the slope of this line is going to be 9 over 30. Any questions about that? Which is around 0.3 or so. So what we can say is that for every year, there has been a decline in clarity of about 1/3 of a meter, which is about a foot, by the way. Any questions on that? So if you predict now, that means it's supposed to go down from 2000 to 2020. Well, if every year there's a decline of about a foot, then that means another 20 feet of clarity is lost, and this lake would get really, really murky. Any questions on that idea? And that's all from the regression analysis. Okay, so anyone know what happened after President Clinton saw this? This is history, not math. They passed a bill. And they said, we don't want this to happen. So they actually funded a huge amount of money to do what they could to try and stop this. So again, this is a prediction. It doesn't mean it's going to happen because there's some things you can do to stop it. Okay, and let me show you now the most current data. Whoops, not that one. One more try. All right, so now we got all the way to 2020. Okay, it might go to 2019. Now, what do you notice in between 2000, which is around when he was here, to 2020? So now if you just look at the data from 2000 to 2020, what do you see?
It's losing its slope.
Yeah, now there is no increase or decrease. So there's no tendency for it to go up or down. Okay, there is ups and downs, and that happens because of weather, right? That's going to happen. You know, we have a whole lot of snowfall, and that's going to melt away and then send stuff down in the lake. And then you'll have drought years where nothing gets sent in. But if you look over time, all of a sudden it's changed. And that's because they made that decision, and they made it based on statistics. That's why I like this so much. They put literally millions and millions of dollars into this to save the lake, and it worked. Any questions on this idea? Not too bad?
Nope.
Okay, so what we can say is that between 1968 and around 2000, there was a strong negative correlation between year and meters. Is that clear? Because as the year increased, the meters went down. But between 2000 and 2020, there's no correlation. The correlation is approximately 0. Any questions on that? Okay, correlation is a measure of how good a fit and how much of a tendency there is as X increases for Y to make a change, a linear change. Okay, and in this case, there's no change, you know, there's no linear change between 2000 and 2020. Any questions so far? Okay, so let's do some problems. I think that's important to practice. Again, I showed you some real important data. Now I'm going to make some up. Let me get rid of this. And let's put something in. Oops, one more time. Takes a moment to get it set up. Okay, so here's what we got. Can you see that, hopefully? Okay, the data below show the results of a study of 9 community colleges done that looked at the percentage of students at community college who received financial aid and the percent who were business majors. Conduct a hypothesis test to find the correlation, then perform the full regression analysis. Any question on the question? Any questions? All right, so what I'm going to do is, and you're used to this, I'm going to write down H0 and H1. I hope you're used to this. So first H0. And it turns out that the first letter of correlation is doesn't quite work for us. Instead, what we're going to be using is this guy. Oops, missed. That's better. Anyone know how to read that? Kaladin, Pooja, Alex. Keep having different people coming in now, which is always interesting. Anyone know how to read that? It's a letter.
No.
Okay, it's a Greek letter, and it's the Greek letter rho, like row, row, row your boat. That's how you read that. And it stands for the correlation. in particular the population correlation. And what we want to do is we want to say, is there a zero correlation? That means there's no correlation between the percentage of financial aid students and the percentage of business students versus H1. And that is rho is not equal to 0. Any questions so far? Okay, so that's what we're looking at. We're looking at this hypothesis test. And hopefully you're used to the fact that when you do a hypothesis test, you want to get a p-value. Is that clear? So let me go and play with my calculator. So we need the p-value. And we also want the regression line. So we're going to get both out of this. So what I'm going to do is I'm going to go to stat. You're used to that button. And then I'm going to go to edit. I'm going to clear out L2. I'm going to clear out L1. And then I'm going to type in each of the values for the two variables. So for financial aid, they were 42, 38, 56, 19, 40, 37, 72, 55, and 20. Okay, and then for business majors, they were 15, 17, 7, 34, 12, 15, 6, 9, and 27. Any questions so far? Any questions? Okay, so now I'm going to go to the stat button. You're used to that. And I'm going to get a test. I use the up arrow. We're towards the end of the class, so we're at the end of what we need to do. And we're almost at the very end. We're going to use the lin-reg t-test. Any questions on that button right there? Okay, then I hit enter. X list is L1, Y list is L2, freq is 1, that's fine. We want rho not equal to 0. That was our H1. Don't worry about reg EQ. And we hit calculate. Any questions so far? Okay, now it turns out the test statistic uses that t statistic, just like we had in chapter 9, okay, and 10. So it uses a t statistic. I'm not going to get into the mathematics of it, that's for sure. But it's -6 or so. Is the p-value 5.02?
No.
No, it can never be bigger than 1. What is the p-value?
0.00005.
Yeah, 0.0005 about. Okay, and then notice it says at the top y equals a plus bx. So a is about 36.9. And then b was -0.5. So that means that the equation of the regression line is y equals 36.9 minus 0.5x. Any questions on any of this? Okay, so now let's go ahead and let's do all kinds of interpretations. So the first thing is our p-value. was equal to 0.0005. What does that tell you? You should know by now. If the p-value is 0.0005, you're supposed to know what that tells you. At least in general. Yeah, so we reject. So that means there is, and this is a very small p-value, so I'm going to use the word strong when we have such a small p-value, statistically significant evidence to conclude that there is a correlation between the percent of financial aid recipients and the percentage of business majors. Any questions? Any questions on the conclusion for the hypothesis test?
So does the rho symbol mean correlation?
Yes. Okay. Yes. Yeah, rho is actually a Greek R letter. Even though it looks more like P, but it's actually R. And R is the letter used for correlation, for the sample correlation. So that's where it comes from. So rho is a correlation. Okay, good question and has an easy answer. The answer is yes. Okay, notice I want to remind you that we had y was equal to 36.9 minus 0.5x. That was the equation of the regression line. Any questions on that? So let's interpret the slope. Okay, so you want to interpret the slope. First thing, the slope is negative 0.5. We could also look at it as negative 0.5 over 1. And remember, the slope is a rise over the run. The rise is the increase in financial aid students, and the run is the increase in business majors. Now, if you have a rise of negative 0.5, that's a decrease. So we can say is that for every half or 0.5% decrease in financial aid students, there tends to be an increase. Rise over run. Yeah, so that's fine. An increase. There we go. Of 1% more business majors. Oops, that should be 1% more business majors. Another way of saying it, if you want, is for every increase of 1% business majors. Wait, do I have this backwards? I'm sorry. Let's see. Rise or run. Rise is business. Sorry, I got it backwards. I knew it was backwards. So for every 1% increase in financial aid students, there tends to be a decrease of 1% business majors. Does that mean that if you give more financial aid, you will have fewer business majors? What do you think? So does that mean that if a college decides to give more financial aid, they will have fewer business majors? Is that true based on this study?
Yes.
Okay, one more guess.
No.
No. Okay, and here's why. Because I use word will.
Um,
Do you see? So that would be a causative sentence. Giving financial aid is not going to cause more business majors. Does that make sense?
so instead of saying will, we should either say there tends to be, or can we say we can assume?
Assume's not good. Assume's always a bad word. Unless
Okay.
you have to. You can say tends to be or predicted to be.
Gotcha.
Those are the two words you use in regression. The two phrases, I guess, in regression analysis is tends to and predicted to. Does that make sense?
Yeah.
You can't say will. You can't say, hey, giving more financial aid is going to drop the business majors, because that is causative. Do you see?
Mm-hmm.
Instead, what you can say is that colleges that have more financial aid tend to have fewer business majors, right? And in particular, for every % increase in financial aid, there tends to be 1%. Sorry, that was a 0.5%, not 1%. Let me fix that. Will it let me fix it? Got to start over, but it's important enough I want to fix it. So for every, one more time, for every increase of 1% financial aid, recipients, there tends to be a decrease of 0.5% business majors. Okay, that was the slope. Okay, the y-intercept is 36.9. Now, is that relevant? Can you have 36.9 business majors at a college? Is that a possibility first?
No.
Okay, tell me why not. If you say no, then why would that be impossible?
Because you can't have 36.9 people.
36.9%.
Not sure.
Okay. There's nothing wrong with saying 36.9% of a college is business majors. Do you agree? Does that make sense?
Yeah.
So that's not a problem at all. Can there be no financial aid recipients?
Yes.
Yeah, not a lot of colleges, but college, that could happen. Okay, especially with these for-profit colleges. Does that make sense? Is that if it's a non-accredited, for example, for-profit college, then you could end up with no financial aid because the government won't help. Does that make sense? So
Yeah.
this one does make sense. So if we're going to look at the y-intercept now let's interpret the y-intercept, which is 36.9. Now the y-intercept is the value of y when x is 0. So what we can say is that our best prediction for a college that has no financial aid recipients, because that's 0, is for them to have 36.9% business majors. Okay, and that makes some sense. Any questions on that? Any questions? Okay, so next is, and let me go back to my calculator because I didn't talk about it and I want to talk about, I didn't want to overwhelm you with stuff. So let's go back to the calculator. I want to show you more things. Okay, you will see if I go down, R squared is 0.84, and R is negative 0.92. Any questions so far? Okay, so now I can go back to my interpretation page. And first thing is, notice, because R, let's have it a different color. Running out of good colors, that's a good one, I think. So let's, since R is equal to negative 0.92, we can say that there is a strong correlation, strong negative correlation between the percent of financial aid recipients at a college and the percent of business majors at that college, at the college. Any questions on interpreting what kind of the idea of negative 0.92? You know what, there's an error here. That was 0.92, much better. Any questions on interpreting the correlation? So just to note, the correlation can never be less than -1, and it can never be greater than 1. So if the correlation is far from 0, then we say there's a strong correlation. If the correlation is very close to 0, then we say there's no correlation. If the correlation is somewhere in between, like maybe 0.5 or 0.6, then we say there's a weak correlation. Any questions on that idea? So 0.9 is very close, negative 0.9 is very close to -1, so there's a strong correlation. Is that clear?
Yes.
Okay. Now, finally, the last thing to interpret is R squared. And R squared is the hardest of all of them. So maybe I'll do it in black, because black is hard, right? Or maybe not. Okay, so let's take a look. And notice that R squared was equal to 0.84. And I like using 2 decimals, and you'll see why in a bit. Okay, and by the way, it's not a coincidence that if you square negative 0.92, you get 0.84 about. So R squared really is the square of R. But the interpretation is very different. So here's what we can say. There is a pretty relatively large variation from college to college in the percent of financial aid recipients. Sorry, percent of business majors. If we only focus on colleges that have a specific fixed percent of financial aid recipients. Then on average, the variation in the percent of business majors is decreased by 84%. So I want you to read that, and because this is, again, the hardest part of the whole chapter is right here, this R squared. So you can see that financial aid recipients, we got a college with 19%, I'm sorry, business majors. We got a college with 6%. We got a college with 34%. We got a college with 15%. They're all over the place. Do you see that? But if you only look at colleges that all have the same financial aid percent recipients, it won't be all over. The business major percents will not be all over the place. There'll be 84% less variation. Okay, and another word for variation is standard deviation, by the way. So any questions on this idea? Any questions?
I'm not sure how I would be able to tell that it was decreased by 84%.
Okay, so the first thing is the calculator gave us a 0.84. You okay with that?
Yes.
The second is if you want to turn to a percent, you move the decimal over 2.
Right.
Okay, so that R squared as a percent is how much the variation on average decreases if you focus on only those with a fixed value of X. And that's always true in every example.
Okay.
Notice if R squared was, say, 0.02, then there would be very little decrease in the variation, 2%. Do you see that?
Yes.
So if your R squared is really small, then the regression line isn't very useful at all. Do you see that? Because knowing X doesn't give you a good handle on Y at all.
Okay, so we're always going to use for R squared the term that it's decreased by whatever number?
Yeah.
Okay, got it.
Because that's what it does.
Okay.
Okay. That's what R squared is all about. There's different ways of saying it, but I found that this is the easiest one for most people to understand. So I've been using this one lately. But it's all the same meaning. You know, if you look in the book, it might be slightly different, but it's the same idea. Okay, any questions on that? So notice when you do regression analysis, there's a hypothesis test for correlation. Then you either reject or fail to reject. Just note, had the p-value been large, let's say the p-value is 0.52 or something like that, okay, very large, then at that point, you say that the regression analysis is useless. So if you can't reject the null hypothesis, then you kind of stop there, because that means this line isn't really telling you anything. Is that clear? Okay, so any questions, any more questions on this? What I want to give you in red now, in bigger font, secret word. And the secret word of the day is tens. Because when you're doing the interpretations for the slope, for example, you don't say will, you say tends. Does that make sense?
Yes.
So I always like to make the secret word have meaning if I can. Okay, so that's, like I said, I wanted to give one example in full depth. It's already a little past 7, not a lot, but again, it's not like we have to review for a test or talk about, project in detail, anything like that. But I do want to let you know this is a good time. Let me go back to the main screen. This is a good time if you have questions about the project. It's a good time to ask. I want you to look at the discussion board because some people have posted ideas and I've done some modifications for them. Take a look what I've suggested for them so you don't make the same mistake. Does that make sense?
Yes.
But the project definitely is what you're focusing on this week. Okay, and chapter 12, which is really important. And in fact, what's your major, Callum, Pooja?
Legal studies.
Legal studies, and Pooja, what's yours?
Psychology.
Psychology. Okay, so the good news is everybody uses regression analysis. So in legal studies, honestly, I'm not a lawyer. I don't know too much about legal studies. Believe it or not, I have been an expert witness, though.
Oh.
Doing some mathematics, as you might expect. Okay, but it was very different. In fact, it was really easy math, but they just wanted me because I had the name as professor. You know what I mean? But you guys could have done the math too. So I don't know legal studies too much, but for example, if you're doing some kind of defense and it involves DNA analysis, then regression analysis could be important because you can look at some kind of correlation between, say, the percent of similarity in DNA and the percent chance that it is a related person. Does that make sense?
Yeah, that's interesting.
Yeah, and that would be something you might do someday. I mean, I don't know what kind of legal studies you're going to do, but that if you're going to do some kind of murder trial that had DNA evidence, that there's a lot of math involved in that, a lot of statistics. And in psychology, it comes up a lot. So in psychology, you do things like saying, well, if you look at, say, how often somebody is drinking alcohol versus how many times they need to go in for mental issues per year or something like that, then that would be regression analysis also. And that would be a psychology example. Does that make sense, Pooja?
Yeah.
Okay, there's a lot. I'm not a expert psychologist or anything. I'm a statistician, mathematician, but I've seen lots of examples in everything because regression analysis is useful for pretty much everything. I'd say over 50% of all uses of statistics in the fields involve regression analysis. That's how important it is.
Do you know how much it's used for research methods? Because that's the class I would take after this.
Yeah, so again, if you're ever studying 2 quantitative variables, okay, and again, there's lots of quantitative variables in psychology where you might want to think one might influence the other one.
Oh, got it.
That's regression analysis.
Okay.
You see? If one goes up, the other tends to go up. Is that clear?
Yeah, thank you.
And it happens a lot. So let me give you an example that I did personally. It was my first thing doing statistics. And believe it or not, it wasn't for statistics. It was for psychology. When I was a student taking psychology, believe it or not. And I volunteered to be a researcher. And we looked at the person's income versus how many racial negative words they used in a conversation.
Wow.
And so the idea is, is there a correlation between income and racism, at least verbal racism? And again, I didn't do this as a statistician. This was for my psychology class. Okay, and it was neat. And what we did is recorded an interview And then we took that recorded and then we counted. We had these criteria. And of course, the interview was about all kinds of things that would bring about racist feelings, possibly. Things like affirmative action and stuff like that, where people can get upset. You know what I mean?
Mm-hmm.
So we kind of like pressed them to see what would happen. So that was an example I used in particular in psychology. My first ever research project that used math was for psychology, believe it or not. I was a sociology major, and this was for social psychology class.
What was the end result to that?
Sorry, sociology minor, not major. What's that?
I said, what was the end result to that?
Well, the very end, you want to hear the absolute truth?
Mm-hmm.
We had to stop the study because we needed to go to good neighborhoods and bad neighborhoods. You know how that is?
Yeah.
Someone pulled a knife on me.
Oh,
The professor stopped the study. Fortunately, I ran and I got away.
oh my God.
It was scary though. Yeah, stuff happens, you know. But it looked like we didn't have a large sample size because of this incident. But it looked like higher income people tend to be more careful with their speech. So fewer words. Okay. Doesn't mean they're less racist though. You got to be careful about that. It just means they're possibly more educated to not say things in public. You know what I mean?
Right.
But again, the sample size got small. And that's called real life. Stuff happens, right? Yeah, that was a scary event. So any other questions? Okay. Again, we got some big stuff coming, the project and then the final exam. And then again, in 16 days, the class is over. So it'll go fast. So make sure, work real hard in these next 16 days. And then after that, party. Do some fun stuff, whatever you like doing. But at least for the next 16 days, really press on this class. Because I definitely want you to pass. And again, with hard work, it can happen, for sure. And do well. And I'll be checking the boards often. What's that?
Oh, like the first project, will you, if we send you our draft in the next few days, will you give us some notes on it? Or
yeah, I'll do that. But I want to remind you, Thursday and Friday, I'm really busy. So it might be a little less detailed if you wait till Wednesday night or Thursday morning. I'll get back to you, but it might be a little less detailed because I have 8 hours of interviews.
Okay, gotcha.
Wednesday, I got time. I have nothing Wednesday evening. Okay, remember I go to sleep early, so evening is it, night's not happening. And then Thursday morning, I'm already interviewing. So that happens. We got to hire good people.
Yeah.
So again, if you send it to me, definitely I'll take a look at it, especially if you send it to me, Wednesday. Thursday, I'll look at it, but it might either take longer or I might have a little less detail to tell you.
Okay.
And I'll do my best, Okay, any other questions?
Nope.
No? Kyle, any questions?
No, all set. Thank you.
Okay, well, we can say goodnight if you want.
Okay.
Next week will be the review for the final, by the way. And that's next Monday.
I'm sorry, what was that?
Next Monday's webinar is we do a little of chapter 13. It's a really short chapter. And then we review for the final.
Okay, is the study guide for the final, are we gonna have one for the final?
Yeah, a little different though. Not quite as much detail because it's more broad, the final. Covers more material. But I'll definitely help you on study guides and where to study and what problems to practice, stuff like that.
Okay, thank you.
Okay, other questions?
No, all set. Thanks, Professor.
All right, well, thank you. And thank you, Pooja.
Thank you.
And we can say goodnight if you want to.
Yep, good night.
All right, and for all of you watching this as an archive webinar, then make sure you do the secret word and please post on the Q&A or the project discussion forum for any questions you might have. And if you can get that project, especially by Wednesday afternoon, as a draft to me, then I'll have more time to look at it. So have a good one, and I'll chat with you more.